Well, okay. We are going to go ahead and move on to the next section today, which is referring to law of sines and cosines. But before we go ahead and get there, just a few things. How many IB students do I have in here? Okay, now how many of you are juniors who will be taking a test this year? Okay, so if you are an IB junior and you're taking a test this year, I've been asked to tell you from Ms. Moore, you're going to need to pay the registration fee. It's $172. It's going to be due on the 15th of November. You can pay it in installments if you need to. Just talk to Ms. Moore. You guys can go ahead and work something out, but only if you're an IB junior taking a test this year. The other big point, the unit circle projects are going to be due tomorrow. Remember, for you guys, this is only extra credit. If you don't want to do one of those, you don't have to. It will not count against you if you don't do that, but they are due tomorrow by the end of school. And I'm going to be recording that as what? As a test grade. Okay, so really the only grades we have left for this 6 weeks are going to be these quiz happy minutes and then that project if you want to go ahead and do so. All right, I think when all is said and done, we're going to end up with somewhere 26 grades for the 6 weeks. Okay, so we're probably going to end up very similar for the third 6 weeks because of the happy minutes. Okay. At the end of the week on Thursday, probably the last 10, 15 minutes, we're going to go ahead and start our district assessment. It's that time of the 6 weeks again. Then we'll go ahead and finish it on Friday. I think that'd be an easy way to finish the week and the 6 weeks. But as far as ending the 6 weeks goes, if you have any outstanding papers, like if you have anything that still can be turned in by the 10 late day period, okay, if you have a retake you want to do that is still available, all of those, everything needs to be taken care of by Thursday morning. Thursday morning by 8:05, because at that point I'm going to go ahead and start finalizing and I'm going to get all the grades taken care of. So if you are failing, you still have grades left, you still have some opportunities, but I would encourage you, don't wait until the last minute. You need to come see me as soon as possible, sooner rather than later. Okay, I think that's everything I have, unless anybody has any questions. Okay, then let's get to it. Now, we've been talking about right triangles because we've been introducing these trig functions to you, and they work great with right triangles. But what if we come across a triangle that does not have a 90-degree angle? Those are the types of triangles I want to go ahead and start to look at now. We refer to those as oblique. And you might remember that when we talked about rational functions, that described what type of asymptote? Yeah, it was a slant asymptote. In mathematics, again, we like to use the same terminology for a lot of different concepts. So you have to know, what it is you're talking about. Here with triangles, oblique refers to a triangle that has no 90-degree measure. So your three angles are either going to be all three acute, or you'll have what? Say it again, ma'am? You'll have one obtuse and then two acute. That is exactly right. Okay. Now, hopefully it was presented this way to you in geometry, but we like to use lowercase letters to represent the side lengths of the triangle, and we use the capital letters to represent the vertices, the angle measures. So, for example, side A is always going to be opposite angle A. All right. Now, the law of sines is very, very simple. Okay, you're simply creating a proportion. It's stated the sine of angle A divided by side A equals the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. Okay, now the only way that you can use the law of sines is if you have what I refer to as a pair. Otherwise, if you don't, you're going to have to use the law of cosines, which I'm going to introduce you to before you leave today. But let's get right to an example. Let's see what you guys think. Example 1, it says solve triangle LMN. Now, when you're given the instructions, if it just says solve this triangle, what that's trying to tell you very quickly is find every missing angle measure and every missing side length that we have. Okay, so this one, round side lengths to the nearest tenth and angle measures to the nearest degree. Okay, so for this one, we don't have to do anything, fancy to find angle N. What's the interior sum for all three of the angles? Yeah, it's 180, right? So I would just need to take 180 minus 112 minus 29. So somebody help me out. What's that going to give me? That's going to give me 39 degrees. So right there, we have all three of our angle measures. Now, what am I referring to when I say a pair? That means you have to have an angle measure and the side length directly opposite that. So here, that's referring to angle L and side L. Okay, that's what we refer to as a pair. You have to have a pair in order to use the law of sines. Okay, so I'm going to go ahead and start with that ratio. I'm going to say the sine of 29 degrees over 22 side L equals. Now, where you go from here just depends on what side you want to find next. Okay, so the ratio is going to be different depending on if I want M or N. Skylar, what do you like? What side would you like to solve for, M or N? What's that? N, okay. So I'm going to have to use 39 degrees. So I'm going to say sine of 39 degrees over side N. And there you go. Now, how do you solve a proportion? You cross multiply and divide, right? So I'm going to cross multiply these. Now for this first one, I'll go ahead and go through all the steps, but from here on, I'll go ahead and just be placing the expression in the calculator. So N times the sine of 29 degrees should equal 22 times the sine of 39 degrees. And then in order to solve for N, I'm going to divide through by the sine of 29. You can divide through by a trig function just like you would any normal value. Okay, that's not a problem. So I'm going to divide by the sine of 29 degrees. Okay, and when those cancel, see that expression is going to give me the length N. All right, so let's actually see what this is going to give me. 22 sine of 39. Let's go ahead and get rid of that. So I always like to use control divide. Okay, so 22 sine, was it 39? Divided by sine, and remember your trig button is right here next to 7, okay, between 7 and the equals, sine of 29. Okay, just type in the expression. So I'd say sine N is about 28.6 units, whatever that is we're measuring it in. Okay, and that's the law of sines. You set up a proportion and solve just like you normally would. Okay, 28.6. Okay, whatever it is we have. All right. Now, you actually have a couple of options here. We have two pairs now. I like to always go ahead and stick with the original pair. Not that it's going to make much of a difference, but what did we do to get side N? We rounded, we approximated, so that definitely would affect M if I use 28.6. You could go ahead and use that value, the approximated one, in the calculator, like we've done before, but you can just kind of avoid all that and not have to worry if you just stick with the original pair. So sine of 29 degrees over 22, the side opposite. So what should it equal this time? Sine of 112 over M. Okay. So law of sines is just a proportion. All right. So now we're going to cross multiply. So I'm going to multiply 22 times the sine of 112. And then what would I do to find M? Yeah, divide by sine of 29. Okay, so I'm just going to go ahead and type that directly in the calculator. So control divide, we've got 22 sine 112, and I'm going to divide that by the sine of 29. So what should I say the length of side M will be? Okay, what do we get? Around 42? Okay, so I'd say 42.1. Okay, 42.1 units, perfect. There we go. That is it. Anybody have questions on the law of sines? Anybody not sure where I'm getting a particular value from? Okay. All right, well, let's go ahead and try another one. Make sure we feel comfortable with it. Solve triangle XYZ. Again, round the side lengths to the nearest tenth and angle measures to the nearest degree. Okay. Well, we can go ahead and find angle Y pretty easy. Jane, what would you say that is? So let's do this. What's 64 plus 41? Okay, we take that away from 180. 75. So we have 75 degrees here. Okay. And what pair do we have? Is it X, Y, or Z? X. Okay, we have a pair, an angle measure, and the side opposite with angle X. So that's where I'm going to start. The sine of 64 degrees over 11, the side opposite that, equals. And Susie, what would you like to solve for? Z or Y? Z, okay. So I'm going to use sine of 41 degrees over Z. Okay, let me go ahead and take this out right here. All right, and then it's just a matter, again, of cross multiplying and dividing. In this case, I'm going to divide by sine of 64. Okay, so let me go ahead and take these off real fast. Control divide, what was it, 11, sine of 41. Now I'm going to divide by the sine of 64. Okay, so what should I be getting for Z? Okay, I'd say 8, because this is the one that's 8.0, right? Yes. So this one would probably be the one exception if I were to go ahead and say round to the nearest tenth, and the 0 would stay the same. So if you just put 8, that would be perfectly fine. You know, if you're an IB student, we're much more concerned with significant figures and things like that. So this would probably be one of those exceptions where if you did just put 8, that would be fine. But if there is a value there other than 0, we definitely would want that. Okay, good. Now I need another proportion for y. Can somebody help me out? Sine of what? So what? Sine of 75 over y? Okay. Now what am I going to set that equal to? Okay. Sine of 64 degrees over 11. Again, my advice is to go ahead and use the same pair that you started with, okay, because you know those exact values. All right, so it looks like we're going to have 11 times the sine of 75 and then divide by the sine of 64. All right, so let's see what that gives me. So 11 sine 75 divided by the sine 64. All right, let's see here. Alyssa, what will that give me? Okay, 11 what? 11.8? Let's take a look. She is absolutely right. That should be 11.8 units. Yes. There we go. That's the law of sines. Okay, questions. Okay. Well, now you're thinking, wow, that's way too easy, Mr. West. We want something a little more challenging. Okay. Now, I will say, so far, nobody has gotten this problem correct today. They keep having trouble with the diagram. So let's see what you guys can do. A person in a hot air balloon observes that the angle of depression to a building on the ground is 65.8 degrees. You'll need to change this. It's after ascending, not descending. The balloon's going to go up, not down. So after ascending 500 feet, the person now observes that the angle of depression is 70.2 degrees. How far is the balloonist from the building? Okay, so you see I've already started a little diagram right here. You've got the ground, little building with a slant roof. Didn't mean to have a slant roof, but it is. Okay, so the big thing here, let's see if we can get the diagram. If you can get the diagram, then what follows is going to be pretty easy. Let me give you 2 minutes. Okay, now remember, we're talking about an angle of depression. So let's imagine the person is standing in the balloon and looking straight out from the balloon so that that line of sight is parallel to the ground, okay, to the horizontal. So from there, we're looking down both 65.8 and 70.2 degrees. Okay.
Okay, so the balloon gets closer to the building.
The balloon isn't getting closer to the building. The balloon's getting further away. So all we're doing is moving up.
Oh, okay, because yeah, because you're going down.
Mm-hmm.
Okay.
It's a pretty uplifting problem. Okay, now right now I'm really just interested in getting the diagram. If you feel your diagram is good, try to solve that problem. Okay, and I'm still showing 50 seconds. You got a decent amount of time. Okay. And yeah, really good idea. Start comparing your diagram to your villain buddies. Talk about if you're getting the same thing, and if not, maybe why. Bless you. Bless you. All right. Now, did anybody actually feel they solved the problem to its completion? Okay, Alex, you think you got it? You're almost there. Okay, well, let's get the diagram set up, and then I'll check back with Alex in just a second. So let's say we got this guy in a hot air balloon right here, according to my wonderful picture. So this guy, he's looking straight out. There's his line of sight, but he's looking down at this building, right? And we have a 65.8 degree angle of depression. Okay, so then what does he do? Okay, the balloon ascends for 500 feet. Okay, so we're going to have this balloon up here again. So we're going to go up 500 feet. All right. But now when he looks down at the building as compared to his line of sight, this is now 70.2 degrees. Does that make sense? The higher he goes, the further down he has to look. Okay, because we haven't moved horizontally, we're just moving vertically. Okay, so we have a triangle that looks like this. Okay, so let me go ahead and highlight this in red. And let me recreate this triangle over here. So you'll notice right here, we are going to have an obtuse angle. Can anybody tell me what that obtuse angle is? What would the vertical ascension and his line of sight create? Wouldn't that be a 90-degree angle? Okay, so right there, that would be 90 degrees, but we've also got that angle of depression that he went down. So Dylan, what do you think? Okay, so this obtuse angle right here would be 155.8 degrees. Okay. What else do we know? Okay, what's that one? Okay, we know the 500 feet. That's exactly right. We know this right here is going to be 500 feet. Do we know that top angle right there? Yeah, because this vertical ascension, again, with his line of sight, is again going to create a 90-degree angle. So what's complementary to 70.2? 19.8. So this would be 19.8 degrees. Okay. And then which side am I actually trying to find? We want to know how far he is from the building. The longest side. So we're looking for the side opposite the 155.8. I'm looking for this right here. Now remember, this base one, that's how far he was originally, but now we're looking for the distance after he went up 500 feet. Okay, so how many people got that diagram? Okay, good, 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 good. Alex, did you get that diagram?
I did, except that I only put X 500.
Oh, okay. Have you got the problem solved?
Yeah, but you got it wrong.
Oh, okay. So then let's go ahead and walk through this. Do I have a pair? Okay, I do? Where? Okay. So if I go ahead and find this angle right here, that'll give me a pair, right? Because I know the angle and the side opposite. Well, what is 180 minus 155.8 minus 19.8? 4.4, so it's a very small angle. So this one right here would be 4.4 degrees. Now we have a pair. So sine of 4.4 degrees over the 500 should equal. Now we want x, this longest side, so we're going to have to use the obtuse angle. Sine of 155.8 degrees over x. And see, the hardest part about this problem was just getting the diagram. Once you have the picture, the proportion, very, very simple. Okay. And then now we do like we did before. We go ahead and cross multiply. So 500 sine of 155.8. Okay, let me go ahead and document B out of there. Okay, so 500 sine 155.8. And then I'm going to divide that by the sine of, it was 4.4. Okay, so let's go ahead and round this to the nearest foot. How far away from the building would this guy be? Alex, do you have it now? Still don't have it? Anybody help me out? Dylan? There you go. 2,672 if we're going to round to the nearest foot. Okay, how many people had that? Good, good, good. 2,672. X, 2,672 feet. There we go. Questions? Anybody not sure where we got something from? Okay. So how can I help you out with that? How do I get what? Oh, how do I get the 4.4? Well, we already had the 155.8 because we knew his angle of depression and we know that his line of sight is going to be perpendicular to the vertical distance we went up. So we took the 90 plus that gave me the 155.8. Now the same thing over here, that vertical ascension is going to be perpendicular to his line of sight. So the 70.2 plus 19.8 is again that 90-degree angle. But now, in order to find the 4.4, the sum of all three angles of any triangle is always what? 180. So we just took 180 minus 155.8 minus 19.8. And that gave me the 4.4. Okay. All right. So how many people rose to the occasion on that problem? Rose, because it's a balloon. There you go. You get it, you just don't want it. There we go. Okay. All right, let's try this one. So another problem. This one is already providing you with a diagram, though. A tree is leaning 10 degrees past the vertical, as shown in the figure. A wire that makes a 42-degree angle with the ground 10 feet from the base of the tree is attached to the top of the tree. How tall is the tree? Okay. Let me give you 1 minute to try this one. Let's go ahead and round this to the nearest foot as well. Bless you. And I believe after this we go to law of cosines. Yes. Okay. Remember, if you're having trouble, just stick to it. Okay, I think one person, Savion got that too, because it's a tree. Yeah, maybe branch out, try some new ideas. Okay. As long as you're using the law of sines, you should be fine. You won't be barking up the wrong tree. Tree puns. Hey, there you go. There you go. Hopefully now the alarm's gone off, you're just pine. All right. So let me go ahead and highlight this because I have a darkened tree here, so you want to be able to see what we have. Okay, so we're trying to find the height of the tree x. So what can I do to help me figure that out? There's something we need. Yeah, we need that other angle. So what is 180 minus 142? So this missing angle should be 38 degrees, and that with the 10 feet at the base gives me the pair I need. So I'm going to say sine of the 38 degrees we just found divided by 10 is equal to, now if I want the height of the tree, I got to go with the angle across from it. Sine of 42 degrees over the x feet of the tree. Did everybody get that set up correctly? Okay. Now it's just a matter again of cross multiplying. So 10 times the sine of 42 divided by the sine of 38. So let's see here. 10 times the sine of 42 divided by the sine of 38. And what should I be getting when I push enter? How tall is this tree? Okay, I'd say about 11 feet. About 10.86. Okay. All right, so x is about 11 feet. That's a P. All right. How many people got that one right? Okay, good. There's more hands going up. So like you see, law of sines, just proportion, very straightforward. As long as you have an angle measure and the side length opposite, you can always use law of sines. But what if your triangle doesn't provide you with a way of easily finding out a pair? Okay, well, if you have a triangle such as this, okay, side, 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 we have to start with what's called the law of cosines. So depending on the side you start with, it's a slightly longer formula, but you'll notice the pattern is always the same. Now we're still dealing with an oblique triangle. What does that mean? No 90 degrees. So they're all three angles are either acute or there's one obtuse and two acute. Okay. So you'll notice, depending on what side you start with, you're always going to start the equation by squaring one of the three sides. So let's say we start with side A. You'll notice, how is that particular version ending? It's ending with the cosine of angle A. If you start the equation with B squared, then you're going to end with the cosine of angle B. C squared, you're going to end with the cosine of angle C. Now there's also another pattern. Whatever side you're going to begin with, what are you doing with the other two sides? Okay, you're taking the sum of their squares. So see, if you're starting with A, you're manipulating B and C. If you're starting with B, you're manipulating A and C and so forth. So you're going to take the sum of their squares and then subtract 2 times their product times the cosine of that angle you're looking for. Okay, now the pattern is very, very important because you won't always be given triangles that are A, B, C. I mean, you can use any letters of the alphabet that you want to. So if I were to go ahead and rename this triangle X, Y, Z, so this would be side X, this is side Y, and side Z, what I want you to do is take about 15, 20 seconds, write out what the law of cosines would be if I started with side Z. Okay. So it's not the formula necessarily that you have to memorize, it's just the pattern. What are you going to be doing with the other two sides? Okay, so if I'm going to start with Z squared, what's the first thing I'm going to do with X and Y? Okay, I'm going to square them. So X squared, Y squared, I'm going to take the sum of that. Then what? Subtract 2 times X times Y times the cosine of what? Angle Z. You'll notice I wrote that bigger because the capital letter represents the angle, the lowercase represents the side length. Okay, so that's really just what I'm wanting to show you. It doesn't matter what the name of your triangle is, your vertices, it always follows that same pattern. Okay, well, let's try an example and see what you think. Triangular area of lawn has a sprinkler located at each vertex. If the sides of the lawn are 19, 24.3, and 21.8 feet, what angle of sweep should each sprinkler be set to cover? Okay, so let me go ahead and draw a triangle here. All right. And what would you like to name this triangle? You just want to stick with A, B, and C? Okay, why not? So A, B, and C. And we know that side A across from angle A has to be 19 feet. We know B is 24.3 feet. And we know C is 21.8 feet. Okay. We're trying to find all three angles. Now, here's the thing. Why can't I use law of sines? Because we don't have a what? We don't have a pair. We don't have an angle measure and a side length across from it. This is a side-side-side triangle. You guys remember that from geometry? The side angle, side, side, all those different triangles. You don't remember those? Do they sound familiar? Somewhat. Okay, maybe not. Okay, that's okay. We're not going to be going over those in a whole lot of detail. But here's the thing. If you're forced to use the law of cosines in order to start a problem, it is okay once you're done to move back to the law of sines. But you have to be careful. You can't just choose any angle that you want. You have to find the largest angle first, just on the off chance it might be obtuse. Because if you go ahead and find him first, the other two have to be what? If he's obtuse, the other two have to be acute. If the first angle you find is acute, then the other two should be acute as well. Well, how do I know which angle will be the largest? What do we know from triangles and geometry? That's exactly right. Okay, we're looking for the angle opposite the largest side. So I'd be finding what first? B. So I want to find angle B first. So since we named it A, B, C, I'm going to be using this middle formula right here. Okay. Now, this may or may not be obtuse, but I'm going to go ahead and tell you, if you find an angle measure, one of the acute angles, and it turns out your triangle has an obtuse angle and you don't find him first, if you then revert back to the law of sines, you are not going to get the correct answer. Sine inverse is only going to be able to give you an acute angle. Okay, and I'm actually going to show that to you tomorrow. But for right now, start with what you believe is going to be the largest angle. So this is B squared equals A squared plus C squared minus 2AC times the cosine of angle B. All right, so now we're just going to go ahead and plug in everything I know. B is 24.3, so 24.3 squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. Okay, now we are ultimately going to have to find an inverse cosine to go ahead and find that first value. So we need to go ahead and get cosine all by its lonesome. Now here's what I like to do, because this is going to take quite a bit if we do it by hand. I always suggest just let the calculator do the heavy lifting. In order to isolate cosine of B, what would you do first if you were doing this by hand? Okay, I would take the terms that are added or subtracted, and I would go ahead and move those over first. Okay, so that I would have 24.3 squared minus 19 squared minus 21.8 squared equals, and then we have the rest of the expression. Well, then what would I do next to get cosine of B by himself? Then I would divide by that preceding product. Okay, so then I'm going to divide that guy over. So here's ultimately what I'm going to get. 24.3 squared minus 19 squared minus 21.8 squared, all divided by negative 2 times 19 times 21.8 is equal to the cosine of B. That's how I would be thinking to put it in the calculator. I would just subtract over the individual terms first and then divide by that product coefficient that we have. Okay. Is this making sense? That way you don't have to worry about rounding. You don't have to worry about anything like that. You're going to get an exact answer in the calculator that you can then use. All right, I'll tell you what. We'll go ahead and stop there because our time is almost up. Just remind me how far we got tomorrow, because all the classes are kind of different. All right, so let's go ahead and get our calculators back on the charging station, please. And we'll continue working with this tomorrow. There we go. The unit circle project's due tomorrow. Yes, sir. Okay.